Well, good morning, everyone. It's very, very nice to see people still signing up for the online remote stream, and so we've got some good numbers there. But also, I suspect that we probably have some folks who are going to be in EN 2006 and EN 4020 and some of the other study spaces on campus. So, there was a question in the chat, and unfortunately I didn't notice it before the lecture started. I've posted a news item to the course website, and in fact, maybe, because this is so important, let me just note that here. In this news item, you'll see there's a reminder that as we discussed last week, we will not be all going back to the lecture theater together because there's more than 100 students registered for the course. However, you have lots of options. So, most of you are probably watching this at home on your tablet, laptop, phone, whatever. Great. There are also options on campus. If you're on campus, you are welcome to go to the regularly scheduled lecture theater. The SI leader, Tasneem, is going to be there, and she's going to put the lecture up on the screen. So if you're in EN 2006, well, hello, maybe drop it in the chat and say that you're in EN 2006. Hopefully that will be a useful experience for people because you'll be in a room with other people. You don't have to have your headphones in. And when I tell my terrible, terrible bad jokes, other people will also groan with you. So maybe that'll be a nice experience. There are other rooms that are available in the engineering building. EN 4020 is somewhere that's available. And there's a whole list of classrooms which are available across campus in education, chemistry, physics, arts and admin, science, and those are rooms that have been designated as places for students to watch remote lectures. And so if you're in there, there are people who are in other classes too, so please respect them and have your headphones and stuff. If you're on campus at all, of course, the mask policy is in effect. So if you're in 2006, if you're anywhere else, please do remember to continue following those masking requirements. But some folks will be in the lecture theater and some people won't. And, of course, while I was saying all of those things and gesturing at my screen, my face was really big, so you weren't able to see it, sorry. I opened ng1020.ca and I went to news, and from news I went to this news about lectures. And so this is the page where we have that information. But lots of people, let's see, we've got lots of good mornings that are in the chat. That's fantastic. And all right, at least one person is in EN 2006, so that's great. One slightly unfortunate thing about doing this over YouTube, there are some benefits and some positives. One slightly unfortunate thing about doing this over YouTube is I don't get to see you in an interactive way, so I don't have a camera pointing at the room, so you can't wave back at me. But still, if you're there, I'll wave at you. So yes, good morning, everybody. So let us continue talking now about new programming concepts and how we implement those in Python. Specifically, we're going to talk today about flow control. So actually, somebody said wave in the chat. That's very nice. So this is actually a very timely question, in fact. So where are you right now? So you can drop the answer to that question into the chat. Where are you? Oh, no, even better. I knew I did this. I prepared a question in advance for you to answer via Top Hat. So where in the world are you? And when I asked this question to last year's crowd, I had a wide variety of answers of places that people were coming from in terms of countries around the world, because of course everything was being done online. These days, hopefully most people are in St. John's. Some people might put the room number that they're in. Some people might put the country that they're in or the province that they're in. Hopefully most people are, if not here, at least on the way, and definitely if you're not here, you should have emailed myself, the lab instructor, or both to let us know so that we can plan for your arrival and stuff, and we can figure out an appropriate accommodation for you, etc. But I am interested in where in the world people are. So instead of countries today, I might see some countries, but I might also see some like room numbers or something. Okay, I'm going to close this question now, and as always, it'll be available as homework later. And so let's have a look at the answers that came in. The answers were St. John's, Newfoundland, yep. The library, 2 people in the library, so say hi to each other if you see each other. 1 person in EN 2006, so small crowd today, but that's all right. Middle East, QE2 library, Torbay, CBS, okay, lots of people, residents. Oh, okay, someone else in EN 2006, but spelled slightly differently. Hey, someone's in the new core science facility. Well, so am I, so hello, nice to see you. Well, it feels weird for me to say nice for you to see me, but I guess that's actually the way it is. So that's where you are. So we can have a very clear sense of place. We know where we are in a physical sense. What if I ask you where you are in a program's execution? That's slightly weirder, slightly more philosophical. So why don't you sort of drop in the chat, how do you think you would answer that question? If you were running a Python script and I said, where are you right now? How would you even answer that question? Some people typing. Let's say it's in the lab and I come up behind you and I say, okay, where are you right now? Right, so we have answers about on campus, longitude, and latitude, that's true. But what if I'm asking you, where are you in the execution of a Python program? All right, so we have input. Yep, so you might point at a particular, okay, so we've got a more specific one there even. So if you say, someone says in a seat, great. Place equals input, where are you? Yep, so if you were asking a Python, if you were using a Python script to ask the question, where are you? Then that is indeed how you would do it. Let me see if I can ask the question in a slightly different way. If I were to ask you, where is the program currently? How would you answer that? So we've got some folks typing. So if I say, where is the program right now? That's a good one. In my brain. Yes, that's good because the program maybe isn't written yet, so it's up here, and then we're going to creatively figure out how to explain to the computer what it is that we want it to do from our brain. Okay, so we can look at a line, a particular line. We can say right now the program is running and it's stopped here and point at a line. Yep, that is definitely one thing we can do. There's a sense in which it is in the text and the code. Yep, so the ideas that we're trying to express are in the text, they're in the code. We have, okay, so someone said we have an interpreter that's executing line by line from top to bottom. Yeah, so we can say the program is right here. And now it's right here. So when I debug things in Thonny, and let me just open our little script that we were working on last time, which unfortunately, I guess somewhere in the process of the exercise, I sort of deleted it because I replaced it with something else. But now I'm opening it again. There we go. Let me bring up Thonny again. So in the process of running this little script that we had, where we had this Monty Python-esque script written in Python, I said we could debug this and we could run it line by line. So I could step over this line and it asked me, what is your name? My name is Sir John. What is your quest? So we're going to run that line. I seek the edification and education of the engineers. And then it asks, what's the average airspeed of an unladen swallow? 10. Okay. So you see that there's this yellow bar, which is moving down the screen, that's saying right now the program is running this, or rather it's about to run this step. I can either click on step over, or I can press F6 and it steps over that line. And we say, okay, now the program is running this line. Now it's running this line. Now it's running that line. Oh, it is lovely. Someone posted a picture of students in the room. Fantastic. It warms the heart. So we have different ways that we can see, or rather, we can look at a program and say, currently it is running here, currently it's running here. And the kinds of programs that we have written thus far in this course are programs in which we run one statement at a time. And if we were to trace the execution of the program, if I were to put my finger on a line and say we're running this, now we're running this, now we're running this, now we're running this, it would make a straight line from the top of the script down to the bottom of the script. So here's the script that we saw last time. We see it does one thing, then it does another 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 thing. And all of these statements are executed in a sequence. So we call this sequential control flow because, well, it's one thing after another in a straight line. They are ordered in a particular sequence. And the computer doesn't decide, I'm going to run this line, and then I'm going to jump down here, and then I'm going to go back up here, and then I'm going to go down there. No, the computer runs the statements we've given it in the order that we've given it. Sounds pretty straightforward, right? So at this point, we have a script which can be run very, very quickly because the computer can do things so much faster than we can. It's dumb. It's not clever in the way that you are with your brain that's capable of doing all these cool things like abstract thinking. The computer can't do that, but what it can do is follow instructions quickly. But if that's all it can do, and if we can only write Python scripts that do one thing after another, and they always do the same thing in the same order, maybe with different input data, and so they compute different numbers or something, but if all they could ever do is do exactly the same thing every time we run them, that wouldn't give us a whole lot of expressive power, and that wouldn't turn computers into the revolutionary devices that they are. There's something much, much more important that's going on than just the ability to do one thing after another in a sequence. So how have we defined algorithms previously? Just go ahead and type it in the chat. And it doesn't have to be word for word with whatever I've said before. Just, tell me what an algorithm is. It's okay if it is word for word. Right, so we've got a process that is a step-by-step kind of process, a sequence of events, a set of instructions to do something. Yep, that's good. It's like a recipe. Yep, that's good. And there's one, so we have really, really important elements of the things that we've seen in algorithms thus far, but in the definition of algorithms that I gave, there was one more important thing that I had said. So it's a set of instructions, or it's a step-by-step sequence of things that you need to do, but there's one other really, really important part. So we said that an algorithm is a step-by-step procedure with decisions. And so, see, that's the element that is missing from what we've been doing thus far. So we started with expressions, so we could write expressions that are kind of like mathematical expressions. Then we got a little more sophisticated and said, let's have statements, which can be either expression statements or they can be assignment statements, so assigning things to variables. Okay, now we've got expressions, now we've got variables. We can write Python scripts now and have things execute one after the other. But the thing that's missing is decisions. And that is actually where a lot of the power of programming comes in, is the ability to have a step-by-step procedure with decisions. And that is why we're getting to those things now, and it's still January. We haven't finished the course just because we have expressions and variables. There's a lot more to learn. So within procedures, we have decisions, such as, so somebody mentioned recipes. Well, I gave the example earlier of baking a cake is very much like an algorithm. You do this, you do this, you do this, and in those instructions, it will say things like add 3 cups of flour, whisk 2 eggs, though not in that order. You would definitely want to do it in the other order. So there's a place where sequencing matters. So you wouldn't want to do it in the wrong order. But then you get to a part of the recipe where it says something like bake until golden brown. Well, that involves checking the thing and making a decision. Is it done yet? Is it done yet? Or maybe it says bake for 20 minutes and then check, and then you're going to take the cake out and stick the toothpick in it. Or if you're like super skilled, apparently you just poke the cake and you don't even need a toothpick. I'm not at that level. That's a different level of baker. But when you have to decide whether or not the cake is done, there's something happening that is more than just step by step by step by step. You could tell somebody, add these many eggs, this much flour, add this, etc., put in for 20 minutes, then take out. But if you don't have a decision that gets made, then you run the risk of, well, maybe the cake isn't done yet, or maybe it's burnt. So you have to have checking, and you have to over and over and over again look and say, is it done yet? Is it done yet? Is it done yet? And when it is done, then you behave differently from when it is not done yet. Oh, somebody's putting emojis of cake in the chat, and now I'm hungry. Thanks a lot. It does look like a very tasty cake emoji, actually. I'm impressed. We've also said that you can have procedures that are like, how do you change tires, or how do you rotate the tires on your car? And then you might say, tighten the lug nut until it's tight, or until you get to a certain number of foot-pounds of torque, or something like that. But again, there's a decision that needs to be made. Is this tight enough? Is it too loose, etc.? Sometimes when we are thinking about mathematical algorithms, we have to ask a question like, is the amount of error that we have encountered within some tolerance? Because remember that any representation of a floating point number is going to have some amount of error in it. Well, once you get to kind of actual normal real numbers outside of a particular bound. But when we get to floating point numbers, we'll talk about where it is possible to represent it perfectly and where we get errors. But almost always, and as we've seen, like when we try to calculate what is the sine of 0 or some other mathematical operations, we've seen that we had numbers that were like 10 to the minus 16 instead of 0. Now, 10 to the minus 16 is close enough to 0 for almost any purpose that you can imagine, but it's not exactly 0. So we often have to ask, if we're going to compute something mathematically, how precise do we need to be? How much error are we able to tolerate? Let me ask you another question. Now, without using a calculator, tell me, what's the square root of 24? So this is something that hopefully will be a little interesting to think about. Well, we know it's going to be pretty close to 5, but not quite 5. So how might we check it? So we have some immediate answers, 4.9. What if I say I want to be more precise than that? So you might say that 4.9 seems like a reasonable guess. So how would you check whether 4.9 is the square root of 24? Yeah, so you could square it and then see if the result is greater than 25 or less than 25. If it's greater than 25, then well, maybe you choose a number that's slightly smaller than 4.9. And if it's less than 25, maybe you choose a number that's slightly greater than 4.9. And then you can keep getting closer and closer and closer to the right answer until you get something that is an acceptably close answer, when the difference between your last guess and your current guess is smaller than some amount. 0.01, 0.001, 0.0001, 10 to the negative 5, 10 to the negative 6, etc. So we've got lots of answers coming in, so I'm going to close this now. And look at the responses. Okay, and we had lots and lots of folks had an answer that was in the range between 4.873979 to 4.923979, which is indeed the correct answer is in there somewhere. And if you use your calculator, you can verify what the square root of the square root of 24, square root of negative 24 would be something different. And so very often when we're thinking about algorithms, we need to think about, when are we close enough? When are we done? Are we going to do something over and over and over until something is true, or until something is less than something else? Or very often we might not even need to repeat something over and over, but we still need to make a decision. If, when I check my weather app in the morning, if it's going to be really cold, I will choose a different coat from if I know it's going to be really rainy versus if I know it's going to be 20 degrees outside. I'll make different decisions about what clothes I'm going to put on before I get out there and start walking to work. Because if I get halfway to work and it's pouring rain, then I'm going to regret it if I'm not wearing a real raincoat. So, one way we can represent this kind of procedural knowledge is with a thing called a flowchart. Anyone seen flowcharts before? I mean, I'm guessing probably, but maybe not. Maybe not. No one typing that? Yeah, okay. So we have at least one yes, that's good. So a flowchart is one way to visually represent a procedure, to represent procedural knowledge, also known as imperative knowledge. And in this course, a particularly key kind of imperative knowledge that we care about is code. So we can use flowcharts to represent the procedures that should be followed by a person when they're looking in a shop manual for a car or for lots of purposes, but we can also use a flowchart to represent the procedure that should be implemented by a program. So in a flowchart, we have three things. There are boxes. Boxes represent activities, things you do, or possibly circumstances you find yourself in. Diamonds represent decisions. So is something true or false? At least the way that we're going to use them. You can have more arrows that come out, but we're going to have boxes and we can have diamonds, and then we have arrows, which allow us to trace the flow of logic, so that's why it's called a flow chart, through the procedure with a finger, which means that we're doing it digitally. There's one reason I really miss being in a room with people, because at some point somebody would get the terrible, terrible joke and kind of groan, and someone else would get it and they'd groan too, and then someone else would groan. Anyway, so digital logic here. But you can put your finger on a particular place in the flowchart, say, okay, my lamp doesn't work, and this is like an example that came from Wikipedia. So my lamp doesn't work, so then you might check, and then you follow that arrow down to this decision box, and the decision box says, is the lamp plugged in? If the answer is yes, you're going to go in this direction. If the answer is no, you're going to go in this other direction. And so our flow chart, you can't actually see all of that, can you? Because my ugly mug is in the way. So if the answer is yes, we're going to go in one direction. If the answer is no, we're going to go in another direction. And so we can trace the logic, the flow of logic through this simple little flow chart and then end up in a place where we need to do something. So flowchart, this is a really, really simple example of flowchart, but flowcharts are useful for all kinds of things. So this is an example of a flowchart from a very, very small part of, I believe, the Apollo guidance computer. So there was logic that said, if this particular circumstance is true, then we're going to go over here and do this stuff. If this other thing is true, we're going to go over here and do this stuff. And by the way, if you were to really zoom in on these slides, you would see that sometimes what they actually point to is not a box, but actually a reference to a different flow chart. So it's like, if this condition is true, then go to flowchart A7 and follow that flowchart and go back. So these things were very, very complicated. There was an amazing picture that I wish I'd included in the slides. An amazing picture I saw somebody sharing this week of one of the women who programmed the Apollo guidance computer standing next to all the code printed out, and it came up to here on her. It's almost as tall as her, which is pretty cool. And because of the extreme nature of the problem that they are working on, life and death, humans depending on the software being correct, it wasn't good enough to just compile some code, throw it up in GitHub and hope it works, right? There was a lot of, there we go, somebody just shared that picture. Excellent. Yeah, what a good picture that was. Thanks for dropping that in the chat. Because of the extreme nature of it, people had to do a lot of work to verify the absolute correctness of every single aspect of every single procedure. And so it involved a lot of really complicated flowcharts like this. But then you could look at the flowchart and you could compare it with the code that had been written and see, do they correspond? And then see, is the logic correct? And separately, does the program faithfully implement the logic that I wanted it to implement? So, more recently, here's another space-based picture. This isn't from the Apollo guidance computer. This is a flowchart. It's actually a thing called a Statechart, which is like a little more complicated than a flowchart, but it has some of the same basic elements. And this is from a satellite that some students that I'm working with are working on. And this is kind of the central piece of logic in the mission control subsystem for this Kilik 1 CubeSat that we're planning to launch in hopefully now 2023. And it's been several years of effort, and it's going to be a couple of years more, but it looks like some students from Memorial University, and who knows, by the thing this launches, some of you folks might be at the level in the program where you can engage in the project, where students are building and designing the software for a satellite that we're going to put into space, which is just pretty cool. It must be neat for the folks who are writing the software to know that that their code is going to be in space. That's pretty cool. So engineers get to do fun things, but this is another example of something that is like a flowchart. It's slightly more sophisticated, but it still includes boxes that say here we're booting up, and then here we do this system check, and then there's this condition where if certain conditions are met, we go up here, and if other conditions are met, we go over here. And then from here, when something happens, we go into this box, and then we can sit in our passive state, and then at the appropriate time, collect data from the Earth, and then at another time when certain other conditions are met, we downlink that data to our ground station, etc., etc. So flowcharts are extremely helpful for visualizing logic. Something that is going to be really important for a bunch of people, well, for all of you, hopefully, is how do you get promoted from term 3 to term 4? So the simple answer is, well, is your promotion average greater than 60%? If so, then you can be promoted from term 3 to term 4, or term 4 to term 5, etc. Engineering 1 works a little bit differently, and we'll see that in exercise 3, which I'll talk about later in this lecture. Now, actually, the answer is a little more complicated than that. Here is the real story on how promotion works in term 3. So when you finish your term 3 courses, then we check and see, is your average greater than or equal to 60%? If it is, did you pass all of your courses? So you have to do both. So if you have 58 in all of your courses, you might have passed all your courses, but you don't get promoted. If your average is greater than or equal to 60, but you failed a course, well, then something special happens. But if your average is greater than or equal to 60 and you passed all your courses, then you can see that we can follow the logic down here, and congratulations, you pass. If this was not true, then we go over here, and there are other things that can happen where, let me try to put my face away. So there are other options, depending on whether this is the first time you failed a term, or depending on whether all the courses are greater than or equal to 40. There might be an opportunity for a probationary pass where you have to write some re-exams, etc., etc. But you can see how you could take this flowchart and put your finger in one place, and you don't have to hold the whole flowchart in your head all the time. All you need to do is be able to answer this one question: is my average greater than or equal to 60? And if the answer is yes, then I move my finger down to the next thing indicated by an arrow. Did I pass all my courses? If the answer is no, then you move your finger over here. And so we can reduce something pretty complicated to a set of very simple decisions. And each decision is pretty easy to check. The whole thing may be very complicated, but each individual decision is quite simple. And so this is really, really helpful for explaining things to a computer, where a computer is dumb. It's not very capable. It doesn't understand things in the way that you and I do. It doesn't do abstract reasoning in the way that you and I do, but it is capable of following simple instructions quickly. So flowcharts are super, super useful. And here's an exercise for you, not an exercise to submit to Gradescope and have evaluated or anything. This is just for fun. But draw a flowchart I mean, you don't have to do it right now, and in fact, I'd probably encourage you to listen to the rest of the lecture, but I would suggest that it would be really helpful to just draw a flowchart for any kind of process that has relevance to you, and it could be something related to school, or something related to fun extracurricular things you do, or something related to anything in your any kind of process that has decisions and actions. Just draw a flowchart for it and see if you can represent that process with the simplest possible decisions. Maybe you need to have a bunch of them, but with really, really simple decisions such that a computer would be able to follow that flowchart. And then ideally take that flowchart and explain it to somebody. So explaining things to other people is a really good way to help build confidence that you actually understand it. It's one thing to be able to draw something and say, yeah, that's probably right. It's another thing if you actually have to go step by step through something and explain it to somebody else where you know they might ask, but what about this? That's a really good way of checking to see that you really understand it, which is part of why some people will say that you don't really understand a topic till you've taught it, because that's the point where you don't get to gloss over the details and say, oh, yeah, I get that. Once you have to teach someone, then you have to have all the details. I don't know if I go quite that far, but it's a useful way to think about things. So in programming, control flow is really, really critical. And we're going to see two kinds of control flow that matter. So we're going to have conditional control flow, which is either we do this or else we do that. And this doing this thing or doing that thing is based on a condition. So it's one of those diamond boxes in a flow chart. We come to a place in our code where we say, if such and such is true, then we're going to go do this stuff. We'll do these statements. And if such and such was not true, we'll do these other statements instead. So there's conditional control flow, and then there's looping, which is we're going to over and over and over again keep doing something as long as a condition is satisfied. So people asked in the lab, and it's a fantastic question. I love to get this question. It seems really tedious for me to have to either, in the first instance, type these 4 statements over and over and over again. That seems kind of silly if I'm typing them into an interpreter. There must be a better way. And we say, yep, there's a better way. So scripts are part of that answer. So then you write a script and then you run the script, but then you adjust the potentiometer on your Grove kit and then you run the script again, you adjust it, you run the script again, you say, this is still a bit tedious that I have to keep clicking run, run, run. It would be really nice if the computer could just do this over and over for me. Well, that's something we're going to see, which is when we start writing loops, which we'll probably do later this week or early next week. So what we're looking at to start with is just conditional control flow. So we are going to introduce a new statement called the if statement, and we'll get to looping later. So a couple of things to notice about this if statement. So first of all, we have new keywords. So what are keywords? Keywords are, so in this case, if is a keyword, else is a keyword. You'll notice here that they have a different color from the other words. Now, it's not because they actually have, it's not because my Python file says, and now I want to have a word that is red, and now I want to have a word that is white, and now I want to have another word that is red. No, instead, in Python, in most programming text editors, a feature that they will add, and you'll notice here that we've already had this where the input function here had a slightly different color from this comment, which had a different color from this string literal. So when we write code in a programming text editor or in an IDE or something like Thonny, whenever you type a special identifier like if, you'll notice it changed color. So I could say if2, all right, so that is a valid identifier. That could be the name of a variable if I wanted it to be, or it could be the name of a function. But the word if is a keyword, which means it's a word that's been reserved by the language. So the language has given it a special meaning. So in Python, you're not allowed to have a variable called if. You're also not allowed to have a variable called else. So let's try this. I'm going to write a little Python script in which I ask the user, what is the temperature? And I'm going to convert that into a float. And then I'm going to do something if it's cold, or I'm going to do something different if it's warm outside. So we have if and else are keywords that have been put in place, and then we'll see the other bit of syntax that we need to know about an if statement is we have if, and then there is some kind of condition and a colon, and then we have statements in here. Then we can optionally have an else clause. So if some condition, colon, stuff, else, stuff. What does that mean? So first of all, if condition. So here is where we put an expression that evaluates to true or false. So a Boolean expression. So given that I have a temperature, and that given that, let me write a little comment here, decide what to wear based on the temperature. There we go. So that's a nice comment that describes things for other people. So what would be a reasonable condition to put here if I want to make a decision about what I'm going to wear today based on the temperature? What constitutes cold? Different people have different answers. What constitutes something that's cold enough that I really want to wear my winter coat and not like a jacket? All right, so we've got less than 0 for some people, less than 10 for some people, might be less than -10. It depends. The jacket that I often wear in the fall is actually shockingly warm, so I'll wear that down to -5 or -10 if it isn't too cold. But sure, let's go with 0. So let's say if the temperature is less than 0. So you'll see here this is an expression. Temp is less than 0. That's an expression which evaluates to either true or false. If temp is less than 0, it evaluates to true. If temp is greater than or equal to 0, it evaluates to false. So if the temperature is 0, less than 0, then let's do some stuff. And that stuff might be, you should wear your winter coat today. And then I might have another statement that says brr, perhaps. Now, what do you notice about these statements that is different from other statements in our little program? Someone said -40. Yeah, -40 does constitute cold. Someone says we should clarify in the question that it's going to be in Celsius too. What is the temperature in C? And in fact, because Python supports Unicode, I can even use the degrees symbol. So I could say, what is the temperature in degrees Celsius? Yeah, good point. Okay, yeah, so they're indented, right. So in the syntax of a Python if statement, we have if followed by a condition, which is an expression that is a Boolean expression, so something that should evaluate to true or false. So if condition colon, then we have at least one, there has to be at least one, but we can have as many as we like, at least one indented statement. So here we're saying you should wear your winter coat today. So if this were to be a flowchart, then we would have a flowchart that has a little diamond in it, and the diamond would say temperature less than 0. And there would be an arrow that says yes, and that would point to boxes, like a box that says print, you should wear your coat. And maybe that has an arrow that points to another box which says print brr. From the diamond, there's another arrow. The arrow says no. So it is not true that the temperature is less than 0. In that case, we're going to do something different. And again, we're going to have one or more indented statements. And in that statement, you might say, it's fine to wear a light jacket today. So far, so good. We have if, a condition, do some stuff. Otherwise, do some other stuff. There's a question here. When do you have to leave spaces when writing code? And I would say when writing code, it's uncountable. It's not writing a code. It's just code as an uncountable thing like sand. You wouldn't talk about a sand, or you wouldn't talk about a well, you might talk about a glass of water, but well, anyway, or an air. It's just a quantity of stuff. So this indentation I get by pressing the tab key, or in fact in Thonny it indents it for me automatically. And in Python, the amount of indentation that is expected and is kind of part of the description of the language, and you can use actual tabs or different number of spaces, but it is specified by a convention that you should use 4 spaces. So when you press the tab key, it is going to give me 4 spaces. 1, 2, 3, 4. You can count them. So our little script here, in our if statement, just to review, if a condition, colon, and that is just part of the rules of the language. If I take that colon out, you might say, oh, come on, I know what you mean. Well, Python is going to say, I don't know what you mean, because remember, Python is extremely picky. It's pickier than the pickiest English teacher you've ever had. But that pickiness allows us to write pretty complex, pretty cool things without having to always go back and confirm, now, did you really mean this? Did you really mean that? The way you would in a natural language. So we are running this program now, and we say, what is the temperature? Actually, let me run it in debug mode so that we can step through it one step at a time. So first we say, what is the temperature? I'm going to say the temperature is 4 degrees. Okay. And so now when we step into this if statement, you'll see the whole if statement is highlighted here. So we evaluate this condition. So what is temp? Well, temp was 4.0 because I said 4 and it got converted to 4.0. Now is 4.0 less than 0? No, it is not, which means we do not execute these statements at all. We completely skip them and we jump down to the else instead. And then we run that and we print, it's fine to wear a light jacket today. There's a great question here. What happens if the user enters 0? Well, what do you think will happen? So let me view our variables here. So I'll run this again. So I'm going to run this and I say, what is the temperature? The temperature is 0. That gets passed to float, which gets converted to 0.0. And yeah, so we have, okay, a couple of answers. So it could be false. It could be an error. Someone points out that 0 is not less than 0. And that is correct. So temp, we're checking, is temp less than 0? And the answer is, well, let's see, 0.0. Is that less than 0? No, it is not. So it's false. And so it gets treated the same as if I said the temperature is 273 degrees outside today, which would be pretty hot. Okay. Yeah, it would print that it's fine to wear a light jacket. Good. And so in a midterm or final exam kind of context, I could give you a little Python script like this and say, if the user enters this input, what is the program going to do? Or what will the program print? Or what will the output be? And you should be able to tell me with that or more complex conditions. So we have these new keywords, and we also have indentation. So the if statement and all the stuff inside of it is considered one big statement, and that's one statement that we can execute by checking the condition and then either doing the stuff in the then clause or the else clause. There's a question, Bengals or Rams? There we go. See, I am only just, excellent, someone said panda, good. I'm only just clued enough in to know that that is a football reference, but not enough to know anything about those teams. I think Lori would know much more about those football teams and have much stronger opinions about which is the correct one. Okay, so for example, this possibly, so earlier we saw an example in which we had this quest script in which one thing happened, then another thing happened. And so the Python code always asked you, what is your name? What is your quest? What's the average airspeed? And then you give an answer, and then it always does the same steps. Now, we could make this more interesting. Instead of having a sequential, purely sequential control flow, we could have an if statement that would allow us to make this a little bit more interesting. So in this particular suggestion, I could say, let's check. Let's ask the user, are you brave? And if you're brave, then you will do, then maybe we print the greeting that says, well, hello, brave brave knight or brave dame. And then you do those steps. Otherwise, you say, okay, no, never mind. That's cool. You don't have to do this. So, or if we want to make it more Python-esque, then you might ask some of these questions in this particular way with some of the words from Monty Python and the Quest for the Holy Grail. So a little exercise, and again, this one is just for fun, not for submission, is take that script that I gave you and change it to use some conditional control flow. So earlier I said one thing that you should do to practice is draw a flowchart to describe anything that is of relevance to you. And now I'm saying take this quest.py and change it to use control flow to mean something. And whether it is this particular logic that I've given you in this flowchart, or if you want it to be something else to test whether or not the brave knight, the brave dame's knight name is particularly awesome, which obviously in my case, I would think that if your name is John, then you're extra awesome. So that must mean that you get to do this special part of the quest or something. Or maybe you say, well, what if the swallow needs to fly a particular distance and it can't get there within a certain amount of time? Then what happens? Well, add some kind of conditional control flow to that script and be fun, be creative. This is just for fun. And then compare again with what your friends did and see who can come up with the silliest script that does the silliest control flow. This is just for fun, but it's meaningful practice as well, getting us familiar with conditional control flow. So there's a question, is indentation necessary? Yes, it is necessary. So in a programming language like Python, so there are different programming languages will have different approaches. In some programming languages, you use slightly different syntax. Like if you've ever used C or C++, you'd use braces to indicate how these things get grouped together, and then the compiler doesn't care what indentation you use. In Python, it is required that if you have something which is part of another statement, so in this case, the only way we see that is statements within an if statement. Later, we'll see other ways that this can work too. But for now, if you have a statement that is inside of an if statement, something that is conditionally done, then it has to be indented, because that's the only way that the compiler knows when you are done with this if statement. So I might print, it's fine to wear a light jacket today, and then I might print, how nice, and then later, no matter what happened, whether we took this branch of the flowchart or this branch of the flowchart, I might want to say, thank you for using the Weatherator 3000. There we go. So I want this to happen, whether the weather is fine. I want this to happen whether we took the true or the false branch of that decision. And how is the computer supposed to know whether this print statement is part of the else clause or not part of the else clause? The only way it knows, the only way the Python interpreter knows, is by whether or not it is indented. So just think about the difference between this script and that script. So there is a significant difference there, and that's why the indentation is required, so that you can tell Python, yep, I'm now done with this if statement. And by the way, the else clause, as I think I mentioned this, but the else clause is optional. You don't have to have an else clause. So you can have stuff that you do if something is true and not have specific things that you do if something is false. That's fine. Okay, so that is another kind of exercise for fun. So let's just talk quickly about exercises in general. We've designed the course. It used to have a whole bunch of assignments, and now we have 4 exercises at the beginning, followed by a smaller number of assignments, 5, I think, maybe 6, something like that. I don't remember exactly. So we are now soon coming up on the end of our exercises part. So the exercises, there are 4 exercises that are for credit in the sense of if you submit something, then you get a point, and if you don't submit something, you don't get a point. But they're not for credit in the sense of I'm not taking the grade and saying, well, you got 10 out of 10 and you only got 6 out of 10, so you're going to get different grades. No, you submit something, then you get the credit for that. And there are 4 of those. exercise 0 and exercise 1, the deadlines are already passed. Don't forget the deadline for exercise 2. If you haven't submitted, most people have, but a few people haven't. If you haven't submitted exercise 2, the deadline is tonight. And then exercise 3, which I've just posted, is going to be due on Friday evening, like I think I said 6 o'clock Newfoundland time. Again, it's not a huge exercise. And you don't have to have it 100% right. You just need to submit something. But it's about practicing with conditional flow control and also practicing with variables too. And so this is something that's going to be really helpful for you. So please do those 4 exercises. And also, I said for fun, so don't submit these anywhere. Although, if you want to email them to me or something and say, look, I came up with a really creative thing in my Noble Quest. Well, that's great. I'd love to see that. Do send it to me if you would like to. But you don't have to send me anything. But this is something where I'm saying just kind of for fun, compare and contrast with your friends. Do them together with your friends, because for these exercises, they are meant to help you practice, and you can do them together. Exercises, work together, work independently, whatever. It's all good. Then there's a question. Are you going to upload the slides and notes for this lecture to the course website? Yeah, I believe I already have. In fact, I'm showing these slides from the course website. Yeah. Someone says you can have multiple if clauses. Yeah, so we will get to, if statements can be slightly more complex in that we can have a bunch of different clauses. Just for today, let's just focus on if and else. The else is optional. You can just have the if, and later we'll talk about if and elif. So those are some exercises that you can work on, and starting next week, we are going to start to have assignments, where assignments are going to mechanically work very similarly to exercises 0 through 3, to these things you submit to Gradescope. So you're going to prepare code, you're going to implement something in Python, you're going to upload that to Gradescope, it's going to be evaluated by Gradescope. The difference, the 2 key differences with assignments, is that 1, it's individual work. So you cannot work together on assignments. You can discuss the course content. You can say, I don't really understand if statements work again, and then your friend can help you or whatever. But when it comes to actually saying, how do I solve this specific problem? That has to be individual work, and that's a matter of academic integrity. And the second thing is that the score that you get will actually count for something. So someone who gets 10 out of 10 on the assignment and someone who gets 8 out of 10 on the assignment will actually see different results at the end of the day. Whereas for exercises, that's not the case. So that is it for today. Any questions? Oh, yes. So someone said, and I had another email that said something very similar to this, that they submitted exercise 2, they passed all the tests, but the auto grader shows blank out of 10. Yes. So that is because I think I set one of the tests to actually be a bonus point. And the bonuses don't really matter when they're exercises, but some people at the end of the day might actually get a score of 12 out of 10 because they did something kind of extra cool and extra special. So I think because I set the bonus, you might not see your full score until the deadline has passed, and then you'll see your actual score out of 10, whether it's 10 out of 10 or 12 out of 10 if you did the extra special thing, and we'll see. Let's see, I have a question. I've been recommended that you should use 4 spaces rather than a tab. Is that just preference? So in Python, there is a thing called a Python style guide, which is not style in the sense of fashion, but is style in the sense of, like, if you write for the Associated Press, they have particular styles, particular ways that they say particular things. How do you describe this group of people? Because, one person's freedom fighter is another person's extremist is another person's, et cetera, et cetera. And so they have style guides where they say, this is the way we talk about this thing, that thing, so that we are clear and consistent and everybody knows what we're talking about. And different places will have different style guides. And they might also say things like, we prefer the active voice in our sentences to the passive voice, something like that. So there is a style guide for Python, and it does say it is preferred for people to use 4 spaces rather than a tab character. That said, when you are using most Python editors, if you press the tab key, what you will actually get is not a tab character. You'll actually get 4 spaces. And so you can see here in Thonny, when I press the tab character, it lines everything up. But actually, if I press left, 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 you'll see these are actually spaces, and there's 4 of them. So if I press tab or backspace, it just jumps ahead or back. It indents or unindents by 4 spaces because that is the preferred thing in Python. It's not incorrect to use tabs, but 4 spaces is definitely what is encouraged. Let's see. For the assignments, will there not be any resubmission? So for the assignments, there will be resubmission. One difference on Gradescope is that I may not give you all of the test cases up front. So for example, you may see that, oh, I have a certain score out of 10, but it's only showing me whether or not I passed 5 test cases. So I'm going to give you some so that there's an opportunity to make sure that your assignment code is actually working at all and giving you some correct results. But because it's for credit, I may hold some of the test cases in reserve, and you might only see some of the test results after. But you will be able to resubmit. If you submit and it says, hey, that's not a valid Python file, you can resubmit. If you submit and say this is a valid Python file, but it doesn't give me any kind of output like I was expecting to get, then definitely you'll be able to resubmit. So yes, you will have multiple attempts to submit exercises. Is the assignment graded by the autograder on Gradescope? Yep, it'll look just like exercise 0, 1, 2, 3, which is part of why we're doing those exercises and practicing. And one new element in exercise 3, by the way, is that although for the first couple, the auto grader was set to be very permissive and you could submit a file with almost any name you like, now we are going to require that you submit a file called exercise3.py, not exercise3.py.txt or exercise space 3. It has to be exercise3.py. And we're going to start getting pickier because that is the way of the world in software. Someone says that's the PEP8, right? Like MLA for essays. Yeah, that's a great example. So PEP8 is the Python extension. Actually, I forget what it stands for. But anyway, PEP8 is a style guide that says, although there are lots of ways to write Python that are syntactically valid, here are some rules that we think everybody ought to follow. And that includes things like use 4 spaces instead of tabs. And there was an excellent analogy that someone raised in the chat. It's kind of like MLA for essays. So you might have the American Psychological Association, you have the IEEE, you have the Association for Computing Machinery. All of these different organizations have different style guides about the way you should do citations and references, or the way that you should format things, or the way that you should refer to certain things. And if you have a faculty member if you're doing a course in a social science, they are probably going to say use APA style or use MLA style. And if you are writing a report in engineering, they're very likely to say use the IEEE style or use ACM style. And that's the kind of thing that we're talking about. So for Python, there is a style guide that is very much encouraged, but it's not. The syntax rules of the language will let you use tabs or spaces, but you're encouraged to use spaces. Is the midterm online or in person? The midterm is in person, February 15th, March 15th, in person, probably 7 p.m. We're just finalizing some of the rooms, but in person. Okay. So I'm not seeing any other questions come in. So at this point, I guess I'll end the live stream. So thanks very much for tuning in. And for those who are able to watch in person, that's fantastic. And for those who are watching at home, that's fantastic too. So I hope you have a lovely rest of your day. And I guess I'll see you in the lab once I'm able to.